Welcome to the channel. Today we are going to diving into an exciting topic, that is distributed database. If you are wondered how many companies like Amazon, Netflix and Google manage their data across the globe, so this is for you. By the end of the section you will understand what is distributed database and what is their architecture, techniques and some real world examples, and where the future is heading you. Let us start the session. So let us see what is distributed database. So a distributed database is simply a database where the data isn't stored in one single place. Instead of it is spreading across a multiple physical location, sometimes in same data center, sometimes across the continent, but the user, it feels like a single unified database. Think of it like Netflix, where you are in India, the US or Europe, you can see the same content, but the data comes from the nearest server of you. So that is said to be your distributed database. Next, let us see what are the key architecture of this distributed database. So the main key architectures are classified as a shared memory and shared disk and shared nothing and hybrid layers. So the shared memory is something that is rarely used. All processors are shared under the one memory. So next is your shared disk. So here each processor has its own memory, but also share the same disk like Amazon Aurora. And shared nothing is something the most of common thing used. So here each node has its own memory and disk, and IBM DB2 and Teradata are fall under this. Okay, so next is your hybrid layers. So hybrid layer is mix and match approach, which is something that's separating and compute and storage. So this is like running a business. Sometimes all employees share one filing cabinet. Sometimes everyone has their own shared nothing, and sometimes you mix the both. So next, let us see the data distribution techniques. There are too many ways of data distribution techniques. One is your replication and next one is your fragmentation. So replication is something that copying the same data across the multiple nodes. If one server goes down, no worries, the data will be still available somewhere else. Example, WhatsApp messages don't disappear even when one server is offline. Next is your fragmentation. Fragmentation is something that breaking data into smaller pieces. This can be horizontal or vertical. Imagine a splitting of your customer database, such as Indian customers in one server and European customers in some other server. Next, let us see the types and benefits. So there are two types, mainly homogeneous and heterogeneous. So in your homogeneous system, all the nodes uses the same database management system and operating system, and that is easy to manage. So heterogeneous is something that it has a different database management system and OS across the node, and it is more flexible but harder to manage. Next, why use a distributed database? Because it is highly availability, and next is scalable, and it is highly performable and geo distribution. Next, let us see about the highly availability is something that no single point of failure, and scalability is something that just add more nodes when needed, and performance is fast access the data closer to the user, and geo distribution is perfect for global apps. So next is your challenge and distributed. Let us see what are the challenges. So here the data consistency across the nodes is tough because of CAP theorem. So next is your replication adds complexity, and network issues can cause us delay, and security across the multiple sites must be rock solid. So these are the challenges. Let us see the distributed SQL database. They bring the reliability of SQL, like ACID transaction with the scalability of SQL, and tools like Google Spanner and Cockroach DB and Yugabyte DB are a great example of this. So next, let us see about the popular distributed data systems. So one is your Apache Cassandra, which is scalable and peer-to-peer, and it is used in big data system. Next is your Amazon DynamoDB, which is fully managed and serverless and also super fast. Next is your Google Spanner, which is globally consistent and used in automatic log. And next, the important thing is your MongoDB. It's very popular and document based and used for sharding. Let us see the applications. So some of the real world applications are cloud native apps, really on them, and global e-commerce like Amazon. And next thing is a financial system where consistency is critical, and IoT and edge computing and managing billions of devices. I hope you all understand about the system. So it is wrapped up with a distributed database as a backbone of a modern digital life, from a cloud app of e-commerce and financial system to IoT. They power everything. So the future is moving towards an hybrid architectures and distributed SQL for strong consistency and global scalability. I hope you understand about this distributed database system. And if you have any clarification related to this topic, feel free to contact me. Thank you.